And we should be live. So now, guys, let us know if you can hear us. Let's see if we have around 50 people here. So welcome to our first live in the series. Please let us know if you can hear us. Give us some comments. All right. Okay, we have yes, you're audible. Yes, we can. Cool. Awesome. So first of all, thank you all for joining us for today's session. This is going to be really exciting project that it's going to probably take around, we're aiming for 3 days, but it may take longer. But we have 3 events scheduled, so we're going to try to fit it all within these 3 days. But just in case we don't have enough time, we're gonna probably extend to the 4th day, and it's gonna be all at the same time around this time tomorrow and the day after, and also on Thursday if needed. So yeah, first of all, what I would like to also share here with you is all of the information about the project is gonna be available in our school group. Let me just put the link here. So this is the link for the school group. And I'm going to share my screen real quick here to show you. So when you join our school group and you click on this link, I'm going to put this link in the chat now in a minute. And on this page, this is our free community that some of you are already members. But essentially what we do here, we actually invite all of the people from our YouTube channel, from Instagram, from TikTok to actually join, and it's completely free. And what we're trying to do here is going to build, a helper community where everybody who wants to learn more about Rhino and Grasshopper can join. And the cool thing about the whole community part is that it's gamified, which means that the more you're active, for example, the more you post helpful stuff, you can actually level up your account. And you see here how people have different numbers, and these are their levels. So the more you're liking somebody else's posts, they're actually leveling up. So the point is that you want to level up because you can unlock some of the perks with us. And here, for example, if you go to the leaderboards, you're going to be able to see what you can actually win. So you can win the live events access on level 3, on level 4 recordings, level 5 freelancing crash course, level 6 questions and answers from our paid courses, level 7 consultation calls with us, and then you have a level 8 extended YouTube tutorials, all of them, all like 200 tutorials, and level 9 is 50% discount on any of our paid courses. So also at the end of the month, we give three people who are first. We give access to How to Rhino Premium, and How to Rhino Premium is our second group that is like a membership. And here we actually, in this group, you get access to one professional workshop per month. This is like the roadmap that we had. So, for example, in August, we had this futuristic jet project modeled by me. Then we had advanced parametric wall by Lazar. And so every single month we have different project that we're going to be modeling. And also every single month we have a different lecturer who's going to give workshops for various topics, like, for example, Midjourney, Cinema 4D, Unreal Engine. Now we have this week we have a D5 for architecture. Then we have ComfUI and Stable Diffusion next month. And we have some more interesting guests coming up next year as well. So again, this is what you will get if you decide to join How to Rhino Premium. And Premium Group is only $25 a month. That's like the low ticket type of group you can join. But what I also wanted to tell you is that here in the free group, you also have the classroom, which is the place where you have some of the free training. So you can actually join the free group and you can watch the free training that we have on Rhino and Grasshopper. For some of you who are not beginners, total beginners in Rhino or Grasshopper, make sure to go here and check out. We have very extensive training on Rhino, and also a very extensive training on Grasshopper. And that's for somebody who's a beginner who wants to start from scratch. Now, in terms of this tutorial, this mini course that we're going to be doing today, it's not for beginners, I must say. Lazar is going to explain in a minute that it's a little bit more, let's say, intermediate to advanced. But again, this is going to be like our longest tutorial ever that we ever did on the channel. So we're kind of excited for it to work. It's going to be a big challenge, but hopefully we're gonna get it done. So that's what I wanted to tell you about the intro. So make sure to go to the link to the school group if you wanna join us. And now Lazar is gonna take over, and hopefully we're gonna start doing this. You guys, if you have any questions, if you have any kind of concerns in the middle of the lesson, Lazar is gonna probably try to answer if he can at that moment. If not, I'm gonna try to collect the questions, and then we can maybe try to answer them later. It's really gonna be intense because there's gonna be a lot of explanations, a lot of really structured code in Grasshopper that we need to have a lot of concentration to kind of pull it through. So we hope that that's gonna go well. We'll see. And yeah, now we're gonna move on. Lazar is gonna take over.
Hello. Maybe as some of you are already some of you know, today we are going to model a tower, parametric tower in Grasshopper. So, and as Dusan said, this is going to be a large Grasshopper definition so far in How to Rhino. So maybe I can start first with the reference images. So let me just find folder. Okay, steps part. Okay, it's here. And now I'm going to share my screen. Dule, share screen here, right?
Yeah.
Okay. So in this live events, we're going to, I must say first that we are not trying to recreate this project, nor we can recreate Zaha Hadid's works. So this project is called Central Bank of Iraq, designed by Zaha Hadid Architects. And in this live, we'll try to, this project we'll use as a reference to create parametric tower. And by going through, through this process, so I will try to explain every detail in step. I also prepare some diagrams and sketches, so for each step, because we got feedbacks from you guys that in the previous live events we didn't explain. We explained with a sketch, but we didn't explain like everything why we are doing. Yes. So today, first, I'm going to show you the sketch and the drawings, and after that, we'll start with the Grasshopper. So you know exactly what we're going to create. Okay, so this is a reference project, as I mentioned. So it's placed in Iraq. And this part, this image is most interesting for our live session, because this part of the facade we'll try to recreate. This part is not, once again, we'll not try to recreate, we try to use as inspiration for our Grasshopper project. And yeah, this is a project. And now I will try to explain you first what we are, how we are going to create this one. So this part, as I said, this part, this image is most interesting because we'll try to model something like this, and we'll try to position all around on the facade. So we'll not have this part here. The top part will be different. Maybe I can share the final result right now, and you can see how the final result will look like once we finish everything. So I'm going to open the final script. So you can see here we have a lot of our script will look like this at the end. And once we finish, it's going to look like this. Let me go to monochrome. So we're going to create this kind of form. Okay, and now I can start with explaining each step. So what will be the first step to create something like this? As I said, this is not like the same as Zaha project. So we have a question: would the video be available after the live session? Yes, it will be available for everybody on our YouTube channel. But the product files will be available on our premium group. Maybe Dula can post the link here as well for the premium. Okay, so now I'm going to open the once again the project. So reference image, and I will explain first how we'll try to create this one. So first, we'll try to, as we can see here, we'll focus just on one element that will be multiplied all around. Okay, so this is the element that we are going to recreate. So first, we'll try to create this element. And how we can create this element, I will explain steps here. So first, the logic behind it is to create this element. Then we are going to multiply this element on one facade. And once we create like a single facade, we need to position it 4 sides, right? But once we try to position it 4 sides, we need to, we'll have a problem with the corners. So you can see the gap here. So we need to fix these gaps. And in order to fix these gaps, we need to modify the corner elements. Once we modify corner elements, we can multiply this one facade at each side, and we'll get something like this. After that, we'll scale upper part. Then you can see the difference between these two. So from this straight point, the straight lines, we'll try to make a fluid shape, so more to look more curvy. So we need to find a way how we can transform. In this one, we'll have like a lot of issues here. I will explain later. And this is probably the I would say the hardest part to create facade. So from this stage to this one, and we'll have a lot of, as I said, challenges to overcome, and we'll work with a lot with the data trees. We need to manipulate, and we need to create the pairs of branches. We need to sort branches first, then to create the pairs, and so on and so on. I will get to that part later. Probably tomorrow we'll create facade. Then we need to create top part, make a glass on the top, and we need to merge these glass surfaces in the next part. And once you merge, we can create the frames. Okay, so briefly, these will be the steps. Now we can focus on creating. So let me start here. How to create this single element? Yeah, today. Okay. For today, we'll probably finish here. So this will be the end, the final geometry for today. So this part. And let me go back here. Now let's focus how to create this element that need to be multiplied on the facade. Okay, I will go back here, and let's focus on that element. Just find the right image. As I said, this element we need to create. But to create this element, we need to find like how this element is created. Well, actually, if we take a look, the rectangular shape is cross section, but there are like 5 different positions or 5 different heights. These ones. So here we have like these 2 rectangles are touching each other here as well. But here we need to create a gap at the height 3. At the height 2, they are once again like touching each other, but they're rotated. And here on the bottom, they're stretched. So we need to find a way how to create all these positions and all these shapes. Now I will explain step by step what we are going to do to create this element. So first, we'll create pairs of rectangles. Do we have any questions so far? Okay, it was only for the dark mode. Okay, so we'll start with the 2 pairs of rectangles, and we'll position at these 5 heights. And you can see I forgot to show this image. Once we create these 5 positions, we will find a way how to. I mean, we're going to loft and to create this vertical facade element. Okay, so once you position at these pairs of rectangles at 5 different heights, we'll make a gap between rectangles at the height 3, and this is the first step. Now we need to take these 2 pairs and we need to rotate them, but they're not rotated randomly. They're like there is a specific position at which these pairs of rectangles need to be placed, and this position is defined based on these 2 points, because we'll use these 2 points to create a vector to multiply later this facade element. So basically, let me go back here. We'll use this vector to align these 2 pairs. So once they're aligned, we'll find the right position, the rotation angle, and this is the second step. And the third step is to stretch. Is to stretch the bottom pair of rectangles, and once again they're stretched up to these 2 points. So these 2 points basically will project on the same plane, and we'll stretch them up to these two points. Okay. Once we stretch, we'll create that element that will be multiplied. Okay. Now let's finally open Grasshopper and create this one. Okay, let me go back. I will turn this off. Open Grasshopper. Open a new file. And first we need to create pairs of rectangles. Let's start with a single point. This point we will position somewhere in the space. And now let's create rectangle. I will use component rectangle. And for the rectangle, we need 4 different, actually in our case, we need 3 different inputs. I will turn off draw full names. And let's create a plane. Plane will be at XY plane. And also I will add possibility to rotate this plane if you want. Later on, based on this plane, we can rotate the whole geometry. So I'll use rotate plane. I mean, this is not obligatory. You can, do without this part, but I just want to add possibility to rotate if you want. Okay. And let's set, I don't know, let's say 30 degrees. And don't forget to check here degrees. Okay. Once we create the plane, we need to set the dimensions for the rectangle. We forgot to install here sunglasses plugin. Maybe we can on the break to to show the name of each component. Yes, this is what Walter said. Can you turn on bifocals? We're going to.
Maybe you can install bifocals from package manager.
Or sunglasses. Yeah. No, we don't have sunglasses here. Let's see for the bifocals. No, we don't have. Maybe we can install this on a break, or maybe right now we can install. I mean,
yeah.
Yes, please. Thank you. What I mean, this is for the. I think this is reply for the. Maybe okay. Now give me a few minutes to install plugin. Sorry for. Okay. Here. Rhino. I prefer plugin sunglasses over bifocals. Login, download. Do you need to log in on your account here? Okay. Sunglasses. You need to restart Rhino. Okay. Yeah, we need to restart. But I will just save this project that we created. I mean, just a few components we created. Sorry once again for this. I like sunglasses better as we like this. Yes. I know. I will just explain you what Walter said. Because you can zoom in the component and you can see all the inputs. Not all the inputs, but some of the inputs you can see directly once you zoom in component. You don't need to connect panel. Okay. I installed. I just need to run the script. Okay, let me open all the files. Okay. Great. Now we have like name of the components, and what Walter said, you can zoom in here, and we have like possibility to see the number of branches, what is inside of the component, and also I mean all the inputs and outputs. All right. Once we created this, sorry, we didn't create a rectangle. We need to define the sides. So for the X and Y, we need to place domain. So I'm going to construct domain. If you want to keep this point as a center of the rectangle, what you need to do. Basically, you need to create domain. So if you want to have like a rectangle with the sides 5 and 4, you need to place here minus 2.5 to 2.5, because this point here should be in the center, and in total this dimension will be 5. Same here for the y. If you want to be like 4, you need to place domain from minus 2 to 2, and this will be the rectangle. So in our case, first let's create a slider, and maybe our rectangle can be 1 by 2. So if you want to have like to be dimension 1, you need to divide by 2. So I'll use expression. For all of you who use draw full names, make sure to rename. So instead of I think if you use draw full names, you need to edit this to, instead of variable x, place just x here. And in the expression, I will type x divided by 2. Okay, and let's create a domain. So this will be domain. In our case, this will be from minus 0.5 to 0.5. Okay, and another dimension can be 2. This is first rectangle. Okay, now we need, if you remember, let's go here. I need to create something like this. So another rectangle that should touch this one along shorter side. So let's use component move. So we need to move this rectangle, and the vector that should be placed for the translation vector we can get from here. So we need to deconstruct this plane, and the vector should be y or minus y. All right. So let's use component amplitude. So to take this vector, so y, and amplitude will be dimension, so larger dimension or length of this rectangle. This one. Maybe we can move this on the bottom, something like this. Okay. So we created 2 rectangles. Now we need to position these rectangles at 5 different heights. Once again, why we're using 5 different heights? Because we need to have 5 different positions in order to create loft geometry and to create this element. So once again, I'm going to use, but first, sorry, we need to combine combine these 2 rectangles inside one data tree. We'll use entwine, and now we should use move. So let's move this. And how we can move them at 5 different positions? We need to use, of course, unit z or vector z, but how to position them at 5 different positions, at 5 different heights, sorry. Let's create a slider. So one option is to, of course, we need to have 5 sliders for 5 different heights. Let's align them. So one option is to, let's say, second height will be, let me check, I already have prepared here, so 20. One option is to do something like this. So this is first, second, third height can be added 30 to the previous one. So one option is to use addition. and to create like third height. Then fourth height can be used to add on the previous one second value. So this is one logic, but logic that I prefer, I mean, with less components, is to delete this one. So I'm going to place these guys. So I'm going to place them inside one list. And instead of using addition to some values with the previous value, we can use mass addition. And what we have here in the partial result, basically, it takes the sum before, let's say, index 3, which is 20, and it add value 30, and we get 50. Then for the index 4, the sum was 50, and it was added 30. So similar with addition, but I think with less components. Okay, and these are the heights that we need to place these guys. Okay, so this was the second step. Now, if I well remember, we need to make a gap here. Let me check. Yeah, so now we need to make a gap. After that, we can loft and see the current result. And after that, we need to rotate. And last step is to stretch. Okay, now we need to make a gap at the height 3. Okay, to create a gap, we will use once again component move. But sorry, I forgot to make a groups. So for you will be later to find what is each step. So this one is will be, let's say, create pair of rectangles. Okay, first step. Second step, to set heights. So set I still need to use this keyboard. Rectangles height. This part here. Okay. Now is to we have a step to create a gap for the third pair of rectangles. So once again, I need to use move, and here we need to have 5 different amplitudes, but actually 4 among 5 amplitudes will be 0, and only for the index 2 will give a like amplitude which is not 0 in order to make a gap. Okay, so let's create 5 different values only for the, maybe I should turn this off, only for the index 2, this part here, we should add the amplitude. But we need to know first what is the vector, and also some rectangle should be moved by 2, another rectangle should be moved by -2. Okay, vector, we can take a look here, should be along x or -x from the base rectangle. Maybe we can create here remote sender. We'll use it later a lot. So I will call it base plane. And we can use receiver keys, base receiver, and I'm going to deconstruct this plane and we'll use X. So amplitude will be X. This will be the amplitudes. And what we have here, one set of amplitudes we need to place in the branch 0. Another set of amplitudes will be set in the branch 1, which is negative. So -2 and the +2. So let me see what we have here. Actually, we already have a vector. Sorry. So one vector is positive, another vector is negative. And if we place it in the move, we make a gap. And with this slider here, you can define the gap between these two rectangles at the position 3. Is it everything clear so far? Let's call it, how I call it, gap. Create a gap for the third pair of rectangles. Everything is clear, I guess. All right. Now we need to rotate. We need to rotate planes. Rectangles and pairs of rectangles at position 0 or position 1 and position 2. There is no position 0, just index 0. Okay. I will turn off all of this. Before we rotate these rectangles, I want to show you why vector that I mentioned here is important. So we create gap. So this is so far what we did, and we'll take these two pairs and we'll align them to this vector. Now I will explain why this vector is important. Let me first create a loft here. So I will make a brep, in the right click at the loft options, and I will set to straight. Okay, and I will make it. Let's move it here. Later on, once we multiply this element on the facade, this vector we are going to use between this point and this point here. So let's make a group once again. So this will be the logic how these elements are positioned on the facade. So once again, between these 2 points. I mean, between these two, or you can use also, let me just delete this one. Yeah, you cannot use this one. So this is the vector that we need. But in order to create this vector, we need to know these 2 points. So first, I will extract rectangles. I will extract their corner points, and we'll need to find the logic how to locate these 2 points. Okay. This is the data tree that we have so far. I already make a post on school and on LinkedIn, this new feature at Rhino 8 version, I think since 12, so 8.12, there is a new option to preview parent viewer. What it does, basically, it shows the path of the geometry in Rhino viewport. So we need to extract. I will take these two rectangles, and I will extract their corner points. And as I said, I need to find the logic how to locate this point here and this point here in order to create a vector. Later on, this vector will be used to align these two set of rectangles. Okay. To locate these two guys, I will use split 3. Can that font be scaled up? You mean font for this one? For the path or for the components? I didn't understand the question. So for the path, for this one. Good question. If you mean for the path. Rhino viewport font for the parent viewer. Rhino viewport font. Okay. This one. I'm not sure. Honestly, I'm not sure about this one. I'm not sure. Can we scale up this font? Probably yes, but I don't know the way. But I hope it's kind of visible. Okay, yeah, we'll move on. Now let's locate these two rectangles. How we can locate? You can see these two rectangles share the same index, which is 2. So in the splitting mask, I will type curly bracket for the path, and I will type here asterisk, because we'll focus on all the paths. So that's why we'll place asterisk. So it will include all paths, and then for the index, we'll type 2. So we need index 2. In the positive output, we have these two guys. Or actually, now I'm thinking maybe we can. Sometimes I'm overcomplicating. Maybe we could just list item in this case. We don't need to preserve the position of this guy. For the rotation of these two pairs at the height 1 and 2, we need to preserve. So here we need to use split 3, right? So here I will place 0 and 1. Why? I need to explain you why. I think I didn't explain this part well. How do we view those fonts? Just preview and parent viewer. So if you have Rhino 8 version, Rhino 8.12 or later, in the parent viewer there is option right click and check preview. So if you turn this on, you will get the paths will be visible in the viewport. Okay, why we're using a split 3? Because I want to rotate these two set of rectangles, but I want to preserve their position at the data tree, because later on I want to load them. It is visible here. Once we rotate them, I want to load them, but I want to keep them at the same position as they were before. So that's why I use split tree, and how their position is preserved. It's preserved like this. So it keeps the same data tree structures, but we have null. And for the negative, for the rectangles that we don't modify, it will be the opposite. So once we take these two pairs of rectangles, we rotate them and we place them back. We place them back here, and they will have the same position. So that's the reason why we use split tree. Here we don't need to use split tree. We can simply use index 2, because here we just need to find the vector. So that's why I said we don't need split tree here. Okay. Once we create this, once we extract these rectangles, let's find the logic how to extract this point and this point. So first, I'm going to use discontinuity to extract their corner points. Maybe I can explain the logic what I'm going to do in the next few steps. Once we extract all the corner points, I will find the average point. So I will flatten all of them the same list, find average. That point will be here, and I will find for the. Let me take this another color. So we need these 2 points. How we can find these 2 points? I will calculate the distance for the left. So from all the points on the left to the average, and all the points on the right to the average. A point which is furthest from the average on the left is the point that we need. So this is way how we can find the point on the left. Point on the right will be a bit more difficult, because that point is not furthest, but it is either second or third distance. So it is either this one or this one. So I will extract both of these two, and later on in the next step I will explain how to find exactly this one. So first, let's flatten the list and find the average. So this will be the average, and now we can calculate the distance. Here we have the list of distances, and I'm going to sort these points based on sort distances, sort points based on their distance, and by default the order is ascending order, but if we reverse the list, it will be descending order. And if you remember, here we have two branches. So let's first extract this one. Maybe we can exploit both of these at the same time. I will use explode. Okay. So if we extract first item, or item with index 0, we get this point, because this point is furthest from the average. But for this branch, as I said, furthest is this one, but this is the point that we don't need. We need this one. But because these two are placed on the same distance, let's check. Yeah, 2.5. Yeah, 2.5. We need to find some of, our point is either placed at 1 or at index 2. So I'll extract both of these and find the logic how to extract the point that we exactly need. Okay, so these two. And now I will give you a logic how we can extract the point that we need. So I will take both of these 2 points and I'm going to project them on base plane. So let's use closest plane closest point, this one. I will take base plane. So these 2 points, let's project on the base plane. Okay, now it's not visible. Okay, just, I mean, this is not obligatory, but we can change the origin of the base plane. So I will use plane origin. So this plane will be placed at this origin. Okay. Let's turn this off. Sorry, I'm going to turn off this one. Okay. So we have these 2 points. These 2 points that are placed on the on our plane. Once they're placed on the plane, we get UV coordinates, local coordinates on this plane. And if we take a look, we know that the point that we want has lowest y and lowest lower y and lower x value. So we can deconstruct these UV points and sort them based on their, let's say, y coordinate. And we'll get this one because that one has the lower y. So let's deconstruct UV and sort these guys based on the y. And I will extract item with index 0. Okay. So we managed to extract points that we need. These 2 guys. Once we extract, I will use component vector, 2-point vector, this one, because I will use this vector. Maybe I can visualize it if you want with a line. We can just create a line. So I'm going to use this vector to rotate pairs of rectangles at the height 1 and 2. And they should be aligned with this vector. Okay. It is part clear how we managed to extract these 2 points. I hope it's clear. Nobody, I mean, there are no.
It's either completely clear or not clear.
Yes. Okay. Yes. Thank you, Sharma. Local oriented plane. Yes, that's right. We have Richard here from our school group. Okay.
Ethan is asking if using the list type.
I don't think. I mean, this is what I did while I was creating this grasshopper definition. Let me show you what issue you can get. I mean, that's a great question. I will try to explain. I'm trying to answer this question. So let's use list item. and we pick this guy here, right, with index 1. And let's create the line. But let me show you what will happen if we change, if we rotate the position. You can see how it's switching between these two. You can see what was the problem, because these two share the same distance. If you remember, here, so Grasshopper sometimes show us either one or another item, and this can be a problem. You can see here. Sometimes it's this point, but sometimes is another point. So that's why you need every time when you sort some kind of either branches of items, points, whatever, you need to find good logic how you want to sort. Sorry, I didn't explain well. Try to use list item only when you're 100% sure that that list will not be changed if you modify some slider that affect to this list or the organization or inside that list. Okay, did I fix? Okay, no. Okay. Now I will. We have a question. How I can access the school group membership pending? Thanks. Okay. Now let's rotate these two pairs of rectangles. I extracted them here, and I will type rotate. But we need to know rotation plane and rotation angle. I mean, rotation plane is the crucial here. How we can create a rotation plane? Let's use. Sorry, I need receiver. This one, and I will use base plane. Actually, maybe we can take this guy. Oh no, sorry. So we need to align. This is the position of the rectangles. So we need to align them with this line that we created. So you can see why axis of the plane needs to be aligned with it with this vector. So let's first create the. I mean, to align, I will use component plane align plane. This one. So we have a plane, and we have a direction, straightening guide direction. So basically, this is the vector based on which our plane should be aligned. But what is the problem here? It is going to align x axis of the plane, but we need to align our y axis of the plane, because let me first make this one smaller, because we need these rectangles to be oriented here. So this is the direction that needs to be aligned to here, and in our case this is y. So we need to create the first plane that has x direction in that way, not y. So simply we can deconstruct our base plane and create. Let me just, yeah, I mean, I will show you one way. And then we can create another construct plane that will have, so y should be x and x should be y, like this. But actually, I will show you first here what can be a problem. So we just first see, no, we need, so this is plane and this is direction. Okay. And we get an angle. Let's go to top view. So we need to take this one. Oh, sorry for the sketch. These guys. So we have plane, and we need to align it like this. This is what we did, and we get rotation angle. So this will be rotation angle, and the plane will be rotation plane can be this one. But let me see. Let me see. Yes, I know what is an issue. Let me just see once again. So turn this off. So we take this one, but the issue is we need to flip. We need to flip x. So x should be on another side. So x should be here. The problem was vector was created. I forgot to visualize this vector, so I will use this vector. Let's use this as origin. So this was our vector to be aligned. So we align along this vector. Simply, it was rotated. So this vector was rotated to this one here. Let's see what we got if we place it back to our list of rectangles. So we have rotated rectangles. Okay. Something is turned. Okay. This is okay. I need to turn off this one. Turn off. Turn off. All right. And if you use combine this one with rectangle that we didn't modify, and if we loft, yeah, it was flipped by 180 degrees, and I know why. Let's go to the top view, because our vector that we reference here is flipped. So this vector should be like this, and our vector that needs to be rotated is this one. So this is vector that we need to align, and it will be aligned here. So we need to flip these two. And now I think we should get the right result. Let's turn this on. Yeah. Let's bake it. I'm going to move it on the side. Yeah. Let's group and see how it looks. Translation vector is between these 2 points. Okay. Is this part clear with the vectors? I can, if something is not clear, I can go over once again. So basically, it is just important which vector you're going to choose to align. So what will be the base vector and what will be the alignment vector. So accidentally, I flip end and start point to the 2-point vector. So that's why we can get a problem. So it is important to set start and end point correctly, and then also to set correctly the alignment vector that we had here. Maybe I can visualize this alignment vector as well. So basically, this vector was aligned to this point, and we calculate the angle, and based on this angle, we rotated first 2 pairs of rectangles. Okay. No questions? Okay. Let me give a name to this group. Let's call it rotation of first 2 pairs of rectangles. All right. Let me open sketches. So this is so far what we have. In the next step, we need to take pairs of rectangles at the first height, so on the bottom, and we need to stretch them. And the stretching position will be based on these 2 vectors, these 2 points that we extracted. So basically, we're going to project them on the bottom, and this will be the ending position of these two rectangles that we need to stretch. Group names. We have group names plus sunglasses readable when zoom out. Menu option. Not sure. Group names plus sunglasses readable when zoom out. You mean for the sunglasses, I guess. Okay. Now we need to extract these 2 rectangles. Once again, I will use split 3. And we need to extract. So we need to place here a splitting mask. Once again, asterisk and then index 0. Oh, sorry, I forgot to type this one. Asterisk 0. Okay. Here we have rectangles that we need to stretch, and we'll keep the rest unmodified. So we'll focus only on this one. So what we need to do? Let's take these 2 points, and I'm going to project them on the base plane. So there's component project. This geometry, project them. I will use our base plane. So first, I will type stretch component and see what is required to stretch. So we have base geometry. So this geometry needs to be stretched, and we need these two inputs: stretch axis and length of new stretch axis. So we need baseline, and we need lines. We need to add here line that this baseline needs to be stretched. So baseline we'll get if we take. So we need to once again extract all these corner points, and we need to find point which is closest to middle point of these 2 guys. I'm just going to top view just to check something. Something is weird. Let me just check. I need to check something. If I created the right. So yeah, this is right vector. Yeah, this is correct. Okay. So we need to take this one. We need to project. Yeah, this is what I did. So let me just see something. Yeah, this is parallel. This is all correct. I need to check something. Please give me a second. Feel free to ask if you have any questions that what we did so far. I'll try to answer while I'm checking this one. Something is, we have some issue here. Yeah, definitely we have an issue. And I'm just checking why. Okay. Sorry guys for this one. When you have like quite big script, sometimes this kind of issue happens. Give me just a moment just to troubleshoot, because what I'm checking, this line should be aligned with our edge. But by some reason it is not. So we should get line like this. Probably I know what can be a problem. I think I know. I think the rotation angle, here, what we use, rotation plane, sorry, was an issue. So what we use here as a rotation angle, we use this one here, right? But rotation angle should be check. Rotation angle is an issue. So rotation angle we use as a center of these two, but rotation angle should be in the middle between these two lines. Let me just check this part. Yes, that's right. Yeah, that's right. I mean, the final geometry is similar, but rotation angle, rotation plane should have origin at in the middle between between these 2 points that we extracted. So sorry, midpoint, this one. So in the middle, and I will use this guy. So let's use plane origin. And I will use, if we take this one as a rotation plane, you can see how just a little bit is moved the whole geometry. Now it's correct. Okay, sorry for this one. And now you can see how these 2 points are aligned with our edge. Okay, now I will take this one should be edge, original edge, and this guy here should be edge to stretch. So the final edge that we need to place here, length of new stretch axis. Okay, how to create these 2 set of lines? First one, first let's find the average position, flatten. I mean, we already have this point. Okay, so this will be first starting. This will be the starting point of the first line, and final length should be this one. So this should be placed in the L, length of new stretch axis. But we need to know what is the stretch axis. stretch axis is this line here and this line here. So we need to know how to extract only these 2 points. Basically, to extract these 2 points, we need to find we can find a closest point. So we'll take all of them. Actually, I will take these points. Sorry, these points. Points to search from will be this input, these 2 points that we project them on XY plane or base plane, and cloud points to search will be control points. What does it mean? We'll take these 2 points and we try to find what is the point among these 2 set points which is closest to these 2 guys. In our case are this point on the right and this point on the left. Once we get these 2 points, we can create another set of lines. And these lines will be stretch axes. And we get pairs of rectangles at the bottom. So we're quite close to getting our final shape of vertical facade element. Once we stretch, we can combine. Let's combine data. This one, and now we can loft. Oh, here we have an issue. I know what is an issue. Yes, I know what is the issue. Here we have, we need to be careful with the data tree, right? So here we have like how many branches? 10 branches, but here we have only 2 branches. So we need to trim data tree. If we trim, let me just check 0.01 axis. Invalid line. No. Let's focus here on data tree. So what we have here, we have 10 branches. So maybe we can just clear data, uncheck flatten, clear data. And here we get what we need, only 2 branches. So simply I just clean the data tree and we get like only 2 branches that we need. And now everything it's fine. In the stretch we get 2 branches where only index 0 is like has a value, others are null. And in the 0 or here we have the opposite. Once we combine, we get 5 items or 5 polylines inside each branch, and we get the final position of our vertical element. If we bake, let's see what we get. Later we are going to multiply, and we are quite close to get like one side. So this is how I mean, this is what we get so far. Okay, we're going to make a short break. Let's say 10 minutes short break. After that, we are going to multiply this one along one line. So to create a facade, we are going to modify corners and yeah, create facade. No, I'm reading this comment. Lazar drink some water, and once again from the stretch part. Okay, yeah, I will explain what it's coming next after the break. How to stop this one here. Short break.
And we're back. Hello, guys. Lazar is still taking a break, so I'm gonna for a couple of minutes, I'm gonna just walk you through one thing that we also wanted to kind of let you know here. So since this is gonna be like quite, as you can see, quite like long and advanced tutorial, we also wanted to tell you something about our course for Grasshopper that we also have for those of you who are maybe beginners and maybe you don't understand anything that we cover here. So, and also maybe you're intermediate, you want to go to the advanced part. So I'm gonna share my screen just real quick to show you what we have there. If you wanna, of course, learn with us, that's also a possibility. So we have three main courses: Rhino for Architects, Grasshopper Complete, and Rhino Side Revit. For this particular session, just wanted to share about Grasshopper Complete because it's connected with what we're doing. So for Grasshopper Complete, this is a course that has around 68 hours of video, and we divided it into three big segments: essentials, intermediate, and advanced. And the idea behind these courses is that we wanted to kind of uh, make a system that is really easy for you to learn Grasshopper, and we really wanted to kind of explain every step of the way. Like, why are you doing the things in Grasshopper? Why are you connecting those components? What's the purpose behind each single one of them? So with this course, which is called Grasshopper Complete course, you're going to be able to go from a complete beginner to the complete advanced level, and you'll be able to create all of these parametric designs that you're covering today as well. So the idea here is that this is not going to be like a typical YouTube tutorial where you just follow us what we do and you copy the exact same things. So instead, we focus really on every single component, like what it is, how does it work, what's the purpose behind all of these inputs, outputs. We also talk about, we also have homework assignments for you to do when you finish the lessons. And our focus is mostly on giving you the ability to create these kind of parametric structures yourself without the need to watch tutorials. So that's something that I wanted to share. We give a lot of focus on mathematics and logic behind Grasshopper because this is something that would really change the picture at the end. Once you understand the mathematics, once you understand the logic, everything else is going to fall into place. So again, once you finish this first essentials module, you'll be able to create your own first parametric scripts. The second module, and you can see, of course, here a couple of lessons. So we cover everything from the user interface, first steps, simple geometry, mathematics, everything that we cover both in 2D canvas and also in 3D environment in Rhino, so you know exactly like what's being modified when you change something. We also have these timestamps, which means that you can actually just click on any of these guys, and that's going to take you to the exact point in the video that you want to cover. Once you finish essentials, the intermediate part is actually going to teach you all of those other components that we didn't include in the essentials part. For that, we actually cover, let me just show you here. We cover, for example, this is just one of the videos. This is just one of the slides for one of the lessons on data tree that we cover. Then this is another one on the sections. This is another one on meshes. This is another one on surfaces. So I just want to show you the amount of information we have here. And our idea here is to show you how some command is used and then how you would use that in architecture specifically, like what's the application, how I would apply that. So once you finish that, you'll be able to really, play with whatever shapes you imagine. We also prepared this PDF document that we call Grasshopper Complete Course Curriculum that includes all of these components in one place. So imagine that maybe you want to come back to some component. Let's say you want to come back to divide curve component. And this means when you find it here that it's located in this video called curves at this point in time. So you know exactly in which video at what time to find the explanation about divide curve component, and then also what are the additional examples of how this is being used. So think about this as some huge A to Z video guidebook that has everything you'll ever need in Grasshopper. And the last part is, of course, the advanced part. The advanced part covers 10 highly complex projects that we did in Grasshopper. These are some of them. Also, this project that we're currently doing is on a kind of same level as these projects. So you'll be able to kind of see the process of how we build projects like these and what's the process behind them. I just wanted to show you Grasshopper in action. So you probably know that you just need to modify a couple of sliders, and then you have completely different design iteration. And that's the beauty of Grasshopper. That's why it's so popular on architecture, because you can simply, with a couple of sliders and a couple of curves, you can modify everything. In this one, for example, we're playing with the front face of the facade. This is the MVRDV facade. And you can see here how we're manipulating that front face. In this one, we're playing with the position of the columns, how they're all interconnected, how you can manipulate that design. And this last one is like the facade example, where you can create multiple iterations of the same design and manipulate also the individual modules, but also the overall shape. So that's Grasshopper complete course. If you're interested, let us know. We can schedule a call and give you more details on it. And now Lazar is gonna jump in, and we're gonna continue from here.
All right. All right. So if you want to have these kind of skills, like, let us know, and Dusha will explain more about that, how you can enroll. Let's go back. So now our idea is to multiply them. So to multiply them, I'm going to use a linear array, but I'm not going to multiply these B-reps that I created. I want to multiply control curves, because later on these curves we need to scale in order to have like this kind of shape. For all of that, I prepared sketches, but I don't know why I'm not showing you and explaining with my hands. So so this is next part. So because, as I said, from here we need to get to this part. So if we multiply these B-reps, it's a little difficult to get this part. So it's easier first to have only curves, and later on we'll get this B-rep. So let's delete this one, open Grasshopper, and so instead of using output from here, I'm going to take these curves, these polylines, and I will multiply them. So I will use component linear array, this one. So we need 3 different inputs. We need geometry, base geometry, direction, and number of elements in array. Okay. Direction will be the same direction that we have here. This is direction. We can flip this direction. Maybe we can flip like this. I mean, it's up to you. And I'm going to call this one. I will take vector. Sorry, I will take vector container, and I will type here. I will type here array direction. In order to see how we call this component, you can turn off here this icon, and we'll have like only the name of the component. So this will be array direction, and I will use hidden wire. Okay, so this will be direction, and here we need to find how many elements we'll have.
Richard shared a screenshot for sunglasses.
Just a second. And this is how we, I mean, here you can define how many elements you will have along this direction. And now I will show you what we need. I mean, what we get in output. So in output, we get the data tree that we don't that we need to modify. Just a second. Yeah, I checked this one. Yeah, I checked this one. Yeah, you can see here big names, nicknames on groups. Maybe I should. Maybe Richard means if we let's try like this. No. This one. Okay. Oh, cool. I didn't know that. Okay, so this is cool. So instead of placing the name, we can just. So I'm going to copy this one. Thank you, Richard, for this one. And if you zoom out, you can get the name. Create a gap for the third pair. So this is how our group is named. Copy, call group like this. Okay. And let's copy this one. Okay. I forgot to name this group. So this group, in this group, we rotate. So I'm going to call it how we go. Scale the first pair of, okay, not scale, stretch. The first pair of rectangles. Okay. Stretch the first pair of rectangles. Okay. Okay. And all right. So if I try to loft these curves, we get an issue because the data tree structure is changed. Instead of having copying branches, and inside branch we should have 5 items, we get something different. Let's simplify, and we get 10 branches. Inside each branch we have 7 items. Let's see what we get in each branch. So these polylines are placed in the same branch, but actually I want this guy here, this one to be in the same branch. So we need to modify. In order to modify this data tree, I will use path mapper. So let's take output from linear array, connect with the path mapper. First step is to right click and to check here, create null mapping. So it will give you the current data, the current organization or of data tree. So A and B, which means we have only 2 levels data tree. Left, you can see left and right, so A and B. But what we need to have 5 items in our case. So 5 items where each polyline represent different height. But our second branch level has 5 from 0 to 4, which means this one, second branch level, should be actually number of indices inside each branch. So what does it mean? We need to take this B and place as an index, not as a second branch level. So let's use, I mean, you can use any letter you want. I use I, which represent, this is index, and index is placed in the brackets, not in the curly brackets. And we need to swipe position of B and I. So here we should be I, and B should be the number of indices. So we should have 5 items in each branch. And let's see what we have. So 5 polylines. And if we try to loft them, now we get what we need. And if you want to visualize, you can visualize with Parent Viewer. Okay. So this is how we manage to multiply this element on one facade. If you want to position this this part of the facade and for all 4 sides, we need to use a mirror. Okay, delete this one. Let's call it multiply. Okay. And what can be our mirror plane? So mirror plane will be, let's go here. So mirror plane should be aligned with this edge. So this will be one mirror plane on one side. Oh, sorry. One mirror plane and another mirror plane should be aligned with this edge here. I'm just showing you what should be mirror planes. So if we take all of them and mirror them, and this one mirror on the other side, I will hide. We'll get these gaps that I explained at the beginning. So we cannot, I mean, still we're not ready to mirror them. We need to modify this element and this element. So this corner facade elements we need to modify somehow in order to fill these gaps on the corners. So let's go back. I will delete. So what we need, we'll keep position. Right now we have only polylines. I will stick to polylines until we get the final position of the polylines, and after that we can use loft to generate B-reps. But as you can see here, polylines at height 3, 4, and 5 are okay, but the problem that we have with the corners are related with the polyline index 0 and index 1. So these two we need to modify, and these two. So first, let's extract polylines placed at these 2 branches. Okay. Right now we have 14 branches. It's okay. But let's extract first branch and last branch. With the tree statistics or with the parent viewer, it's up to you. You can extract all paths. And I need only first and last. So I will use a list item. Only these two. So we need to extract 0 and -1 item. Uncheck multi-line data. And here we have these 2 branches. I mean, these 2 paths. these two guys, these two, we need to place at split tree. Split tree, because I want to modify content inside these branches, but preserving their position at the data tree. So that's why, once again, we use a split tree. Okay. So here we have. Let me delete this one. So here we have polylines inside the branches. Branches 0. I mean, first branch and last branch in data tree. But we don't want to modify all of them, all polylines. We just want to modify indices 0 and 1. Which means, once again, I will extract them. Let me just think if we need to use split tree. Yes, we'll use split tree, but I will get to that part. First, let's move. Let me just select this one. So this one will be unmodified, and let's move only on these two guys. Right. Let's find the logic first. I will explain the logic how we want to modify these 2 point lines. These 2 point lines. I will give you a sketch here. So this is what we have so far, and I will take index 2. I mean the point lines at level 3 to find mirror planes. So we still don't have in our Grasshopper file mirror planes. And mirror planes we get from these 2 guys. One is aligned, you can see here, with this edge. Another one is aligned with another edge. Mirror planes. Okay, and these guys need to be modified. What we need? We'll create a plane. Let's focus on the mirror plane 1. I'm going to zoom in this part. We need to take these 2 points and these 2 points and project them on the mirror plane, like this. Once we project, we get new control points and new polylines, and we can create this corner B-wrap. And the same on another side. This is from other side. Another mirror plane, and these 2 points, these two set of points, we are going to project on the mirror plane, new position, and based on these 2 new position, we'll have polylines and create B-wrap, and we get like these corner elements. After that, we can mirror. Okay. First, let's create mirror planes. Mirror planes, as I explained, we get from the items position at index 2. So list item, and I will type list item 2. Okay. And easiest way is to use bounding box for each one. bounding box orientation plane will be our base plane. And simply with evaluate box, we can extract positions. So we need to extract this position. I mean, either point, I mean, you can use any point at this line. So from 0 to 1. Okay. So what I want to move plane along X. So this is point that we need. And the mirror plane we can get if we take this plane that we get from the evaluate box and deconstruct. So this will be X and this will be Y. So unit Z will be Y and Y direction of this plane will be X. So basically just deconstruct plane. Oh, sorry. Deconstruct plane and construct a new plane. Construct plane. Same origin, Y and unit Z. So this is one mirror plane. Okay, now we need to I forgot to extra. So here we have two branches, but I focused just on one. I didn't focus on another one. So that's why we need to explode data on the explode tree. First explode. Yes, explode. So this one is okay. But we need to have another plane. So I'm going to copy. And this one will have another, I mean, we need to set another values to evaluate box. So this will be 0. Yeah, actually this one. No, should be this plane, which means Y should be 1. We get this plane, and you can see what is the problem. Not Y, but X will be X of our mirror plane. So this is the plane that we need. Okay, another mirror plane. Great. So we managed to generate 2 mirror planes. Any questions so far? Wait, we are lagging 10-15 seconds. But I guess, yeah, I also guess we don't have any questions. No questions. I hope somebody is following this live. We are not alone here. Are we alone? Clear. Okay. Thank you. Oh, Richard is still with us. Okay. So now I will take items to place with index 0 and 1, and I want to modify them. I want to modify these polylines. So let's select items 0 and 1. I was following until I got stuck. Feel free to ask where did you get stuck? Where did you get stuck? On stretching part. On stretching part. On stretching part. Okay. But right where, I mean, at which point At which point? So what was, did you set correctly stretching a line, stretching axis, and how it's called another input? I always forget. Length of a new stretch and stretch axis. So make sure that these two lines you set correctly. And make sure that you set data tree correctly, because here we should have only two branches. Did you right click here and check invert? Because here we should have, by default is set to false, but I you can create a toggle and set to true, or you can simply right click and click on to invert. So to invert default input, default version was false, so now it's true. Walter is still with us. Okay, let's move on. So I selected selected index 0 and index 1, these 2 point lines, and I want to modify them. So let's extract corner points with discontinuity. And I want to select only these 2 points. So these 2 points I want to I want to change their position. Only these 2 guys and for these 2 guys. How we can select only these 2 guys? We can select them with the closest points, not point, this one. So I want to select 2 closest points. I will ask about in details in school. Yeah, feel free to ask. Feel free to send a screenshot and explain where do you get stuck. Okay, so I want to select, so cloud of points to search, this one, points to search from, no, so points to search from here. So, sorry, I was confused. Cloud of points to search. Okay, cloud of point to search will be this point here. So once again, we need to explode data tree. Let me just check if yeah. We need to explode data tree. But here we should have like 4. Yes, we selected 2 items. That's correct. And once we selected one, the best way to we can either select like this. So here we have 2 point lines, or you can use split tree. It's up to you. So here we have these 2 point lines, and here we have point lines on the left side, on the right and the left side. Okay, correct. Now I'm going to extract control points, and cloud of points to search this one. So, and cloud point to search from will be this point. And here we should set 3 number of closest points to find. I want to find 2 closest points. So what I did here, I will take this point, and I want to find 2 closest point at each branch. So these 2 are on the branch 1. and these two are in the branch 0. And this is what we have, right? Same for this, for the point lines on the left side. We have point lines on the left side, cloud the points to search. So among these points we want to search, and here I should use another guy. And I mean, this point is actually origin of mirror plane. Great. So let's focus on the right side now. And these 2 points I want to project on the mirror plane, on this plane. Now we can make this bigger. Let's say 4. So these 2 points I'm going to project on this plane, or on this surface. But it is really important to set direction of the projection. Direction of the projection should be aligned with this line. And do you remember how we can get this line? This line we can get if we take base plane and we rotate that base plane. So, but rotation angle will be the same as the one that we calculated once we rotated rectangles at the height 1 and 2. So I will take base plane, this one, and I'm going to rotate plane. And here let's find the rotation angle. Rotation angle is here. Let's create a remote sender. Rotation angle. Okay. And let's use remote receiver. Select rotation angle. Okay, now we have from the rotation. So from the rotated plane, we get. I mean, we can get projection direction. Deconstruct plane. It will be y-axis of plane that we have here. So let's use project along these 2 points. I mean, these 2 set of points. I want to project on this plane using this one, and we get new position of the control points. But how we can place these control points back to our list of control points that we have here in order to create proper polyline? We're going to use this index of closest point. So I need to use these 2 index numbers in order to replace these points with points that we get here. So there is component replace items. So replace items. So these items, I want to here is items to replace with, and here we have index number. So replacement index for each item. And let's see what we get if we create polyline. Right click on invert in order to create closed, or you can use the Boolean toggle with a true. And we managed to create these 2 guys. Now the same thing we should do on the left side. So let's use replace, not replace, sorry, project along. So these 2 points, I want to project on the plane, and direction will be y. Great. And replace, but we're not going to use this, but these contour points. Okay. So this will be the items, and index we can get from the closest points. Perfect. Now we need to position these point lines back to our list of point lines. So what we need to do, we need to replace once again, but in this case, we need to replace items, and items will be point lines. Index numbers will be 0 and 1, and items will be these point lines. Yeah, but here we need to, okay, I know what here we have all point lines, but I want to take only branch 0, and only for the branch 0 I want to replace items. Great. 0, 0. Just a second. 2 point lines. Data tree is modified here. Just a second. 0 and 1. 0, 0. Yeah, we just need to flatten data tree. Just a second. 0, 0. Okay, and same thing here. But I will take 1, 6 items, and items will be 0, 1. Now, issue that we have is, I think, related with data tree. Yeah, with the data tree, you can see that this data. Let me just check here. Yeah, data tree that we have, for the point lines, has 3 level branches. This one has 2 level branches. So we just need to either to trim tree. This is one way, and we get the right data tree. Let me check just how I solve this issue. Okay. I didn't use. I mean, it works. It works. I mean, for the project file that we'll share once we finish with the whole project, in that file, I mean, this part it's a little bit different, but maybe we can share both of these 2 files. It doesn't matter. Anyway, we get the proper data tree. 0, 0 and 1.6, and these two branches are missing here. Not combine. We need to use merge. Let's check. Okay. Let's see what we get. Now, if we loft, do we have the right result? Yes. Okay, great. Let's bake. Okay. You can see how we modify these corner parts and on both sides. And if we mirror, there is no gap. And also here. So we managed to fill the gaps. I'm modifying the corner elements. I'm going to make this, select this group. And let's call this group adjusting corners. Adjusting corners, and this one can be called, no, actually, this is also adjusting corners. Okay. Now let's mirror. Let's mirror these vertical elements. Still, we are not ready to loft. So I'll use mirror, and one mirror plane is this one. Let's create a remote sender. Mirror plane 1. Oh, sorry, not receiver. Rename mirror plane 2. Okay. Now we should use remote receiver. Mirror plane 1. Great. Let's place in the entwine. So in the branch 0, branch 1. It is really important to uncheck flatten inputs. If we don't uncheck, all the items, so all point lines will be placed in one branch, as you can see here. If we, by default it's checked, so we need to uncheck it, and it will preserve all the branches. So all in each branch we had 5 items, and all this structure is preserved and added with a new level. So let me just check here. Yeah, I know what is issue. One more thing which is important related to data tree. This is also one cool trick. Sorry, but before, how come you don't add the curve to telepathy? How come you? Which curve, Walter? Hmm? Doesn't require connections. But his has. How come you don't add the curve? Don't add curve to telepathy. Can you maybe clarify your question, Walter? Maybe he asked for some input to create a so sender, or just like a wire. You mean like a wire?
He's asking about the wire, right? Telemetry doesn't require wires.
Yeah, we'll see. So let's focus here on one important thing. Input of base geometry has 14 branches. So 14 branches, you can see here. But output is 14 branches. But take a look at the data tree structure. Here we had like tree with two level branches, where the main path is from 0 to 1, and the second path is from 0 to 6. But right now we have, after mirror, we have only, I mean, if we simplify this one, we'll get single level data tree from 0 to 13. So how to have the same data tree organization, data tree structure? We need to right click here and to check principal. It means the output will have the same structure as input placed in the G. And now we get what we want. Let's focus on the main curve you keep referencing. There is no main curve that we are keep referencing. We keep modifying this set of curves. Or maybe I'm wrong. Maybe I didn't understand the question. I mean, if there is one main curve we are keep referencing, that will be like too many wires overlapping. Okay. And we mirror these curves, these point lines. Once again, I want to mirror. So this one I want to mirror, but I want to use mirror plane 2. Mirror plane 2. And we get point lines on the other side. Once again, take a look at the data tree. Okay, now it's okay. Let me just check. Yeah, now it's okay. Yeah. Okay, and now let's place an endpoint to put them in the same data tree structure. So now here we have all curves. Let's mirror. Okay, there is issue here. Issue. Okay. This is okay. Okay. My fault. Previously, I'll explain that we don't want to have flattened inputs. So uncheck flattened inputs. And now it's okay. Now it's correct. Let's see what is our next step. So we finish with the element. Let's find next step is to get from here to here. So what we need to do, we will select items at the branches, items 3 and 4. So at the heights, it's 4 and 5th height, and we will scale them. And after that, we can create a loft and see how the structure looks. This is quite straightforward. Also, this group I will call mirror. Okay. And I will select items 3 and 4. So split 3. First, I will select item either 3 and 4. It's up to you. Because once we select these items at the same height, let's say I want to select these items, I can extract their centers, I can flatten the centers, and I will get a center scaling center. So let's just set here all paths, but only item 4. Perfect. As I said, this is quite straightforward. I will extract area. I will flatten your centers, scale. This will be the scaling center. Sorry. Area. And no, sorry. I want to find the average of this scaling center. Sorry, I forgot to mention that part. So we put all the centers in the same branch, and then we find the average point. And this will be the center scaling. And let's use scaling factor. We can set 1.3. Okay. And the same thing I want to do for the item with the index 3. So here we have the rest of data tree, but from the rest, I want to scale only item within the index 3. Same logic. Same scaling factor. Okay, and here we have unmodified curves. Combine them. Combine data. Combine. I'm going to zoom in here and add one more input. All right. Let's see what we get. Strange sound from microphone. Strange sound from microphone. How do you hear us? Let us check. This, I mean, we didn't change this part.
Okay, guys, so can you describe what are you hearing? Are you hearing a different type of sound or like radio? Okay. Okay, now should be good. How about now?
Static on my end, noise.
How about now? Is it better now? Test. Let's do a sound check.
better.
Okay. So it was the problem with the software that we're using for streaming sometimes modifies the audio inputs on its own for some reason. So if you notice that there's a problem
Again. Still can hear it. No, it started again.
Okay.
No, it started.
Test. Okay. I can modify to do this. How about now? Is this better now? Is it better now? Or is it the same? It could be the problem with the stream as well, with the speed. Okay, let's go like this.
All right, better now. Okay, let's hope it will stay like this. Better. Okay. All right, much better. Let's work. Okay. No, it's good. Okay. I will turn this off. Turn this off. And let's see what we have so far. Let's bake this one. Perfect. Next step is to modify this geometry from straight faces from straight edges to fluid edges, so to have like more curvy shape. I have a sketch here. Or maybe I can just show you what I showed you in the beginning. So from this point, from here, we want to get something like this. So you can see how it looks like more fluid. There is no like this straight edges anymore. Before we get to this part, I want to explain the logic behind this. So this is our geometry so far and our curves so far. So if we take these curves and use loft, not straight loft, but like default loft, we get shape like this. And you see what is the problem. I zoom in this part and you can see overlapping. So there are two overlappings. Here. So which means we cannot use, we can use normal loft, but we need to have more control polylines. So more polylines that will control the shape. So this doesn't work, right? So I will simplify. So let's focus only on this part. So here, like in this part, I try to convert into the drawing. What we want to get curves that goes through these points. So these 2 points are crucial. So we need to have curves like this and curve like this. We cannot use interpolate because it will get like weird shape when it starts going through next through the next curve. So we need to add more control points. So let's start if we have only 3 control points. We get this kind of curves. But as you can see, these curves are not going through these 2 crucial points. So if we try to add more control points, so I added more control points, it's better, but still they're not going through these two control points. So the crucial part is to add control point that will be in the same vertical line. If we add control points at this line, you can see here we added 2 control points, and see what we get. We get curves that goes through these center points. Later, why these points are crucial, because when you try to create facade, it's important at each height, at each 5 height that we have, actually 3 height that are in the middle. Let's not focus on the bottom and the top part. So these 3 heights in the middle, curves needs to go through them. This is one of them. So what we need to do? We're going to select these 3 curves, or these rectangles, at the height 2, 3, and 4. So 2, 3, and 4, and I'm going to multiply it up and down, like I did here. So we added here control points and here, and these are original one. So this is what we need to do with these 3 set of polylines. So you can see at each height, instead of having 1, we have 3 polylines. And now with the normal loft, we get curves that we want. So this is what we're going to do now. Let's delete this one, and this will be the last step for today's live session. Okay, I'm going to once again use split 3, and I will select items 2, 3, and 4. While I'm selecting this, feel free to ask if you understand the logic behind. Loft function with shape diver. I haven't tried. Now I'm thinking why split 3 will not be the best option. Split 3 we use when we want to preserve, I should select here 1, 2, and 3. But why split 3 is not, split 3 we use when we want to preserve position inside the data tree, inside the list. So let's say we want to modify these guys that I selected here. We modify them and we place them back to data tree. But in our case right now, we're not going to modify them. We want to duplicate them along -z and +z. So in total, we'll have more items than we have in original tree. So that's why split 3 is not the right logic. We'll not have later 5 items. We'll have let me calculate. Here we'll have 1. Here we have 3. Here we have 3, 3, 1. So in total, we'll have 11 polylines. So I will delete this one, and I will select items that are not 1 and -1. So first and last, I want to remove them from the list. And these guys, I want to multiply. So each of the point lines, when I said each of the point lines, it means we're going to graft where each point line will be placed in a separate branch. So each one we want to move, actually to copy along positive and negative z vector. So we're going to move unit z, and here we should have 3 amplitudes. Minus x, 0, and plus x. X is a value for how much we want to move. So 3 inputs. Middle input will be 0, which means we want to preserve position, and we just want to preserve this one, and we want to move or copy up and down. Here will be negative value, and let's set number 3 like this. So what we have, -3, 0, and 3. And you can see that each of these point lines be multiplied up and down, and keeping original position. Okay, and now right now each branch has 3 inputs. So for example, this one, and this one are in the same branch, but I want to have 9 items inside each branch. So 3 from here, 3 from here, and 3 from here. So 3 from each height. So that's why I want to trim 3. So 9 items. Let's extract just one branch to see. So these 3 point lines are placed in the same branch. So I want to add bottom and top point line, and we can get it from here. List item. This will be the index. Okay. So I'm going to use in this case insert items. So I want to insert items to each list, to each branch. So list to modify. Here we items to insert will be these ones. I'm going to simplify to keep same data structure, and we need insert an index for each item. It will be 0, and a list length or number of items inside each branch. I will use list length. So that will be 1 insert an index, and 0 will be 1. But let's see what we have here. Item 0 will be only placed here, but actually 0 should be placed at each of these branches where we have 9. So how we can do that? There is component longest list. Basically, it compares all the inputs and see which input has longest list. In our case, this is input B, and it will place all the items from the, in our case, item A, to have the same structure, data structure as longest list, which in our case is B. So let's see how A looks. It will have the same data tree structure. Now we can merge them. And now all the branches have 0 and 9. This will be the insert an index. Okay. Let's see what we have if we love them. Ta-da! This is what we have. So we manage to create this kind of fluid, the fluid shape of vertical facade elements. All right, guys, this is what we're going to stop here for this live session. Tomorrow we'll keep focusing on how to create facade, and I think this will be probably the most difficult part, how to create glass between these vertical elements. But tell me, what do you think so far about today's session?
Maybe you can show for tomorrow what's gonna.
Yeah, let's just see the comments or the feedbacks from today's one. It's good. Few hiccups, but that's from my development. Yeah, I also.
I mentioned this at the beginning that it's probably gonna happen.
Yeah. We also get a hiccup with the rotation, with the rotation part. Thank you for sharing your logic live. You're welcome, Walter. Okay. So tomorrow, I'm going to show you how we can create from here, how we can create, how we can fill this space between facade vertical elements. So I will show you how we can create pairs. So first we need to sort the branches, and we are going to create pairs of branches like this, and we're going to do it with path mapper. It will be a bit more advanced, this part. And once we create this these pairs, we'll fill the gaps, this part here. And after that, I will show you how we can create another pairs of vertical elements, filling this part. And this will be, we are going to merge between these two results, creating, filling these gaps between. So tomorrow we'll focus on this part. It looks like much. I explain you in just few sliders, but trust me, it will be probably not as long as today, but it'll be at least 2 hours. Lots of different concepts covered in terms of data structure and data manipulation. Yet, even tomorrow will like be a big focus on how to adjust and manipulate data tree. I lost connection a couple of times, so looking forward to recording access to be ready for tomorrow. Yeah, it will be on our YouTube channel. Thank you. Is the video going to be available on YouTube? Yes, it will be available on our YouTube channel. Just click on tab live. All right, guys. Almost broke Dushan's 3D printer.
Yeah, so that's gonna be it for today. We're gonna wrap it up here, and yeah, tomorrow we're continuing back where we left off, and yeah, hope to see you tomorrow as well if you can join us tomorrow. And if you have any questions about this session, you can also either post it below in the comments, or you can actually go to our school group. Once again, let me give you the link. So it's either the pinned comment here in the chat, or just type school.com/Rhino, and you can also join our community there and interact with other architects, designers as well.
All right.
All right. Bye-bye.